Hello everyone and welcome to 17th lecture of Global Navigation Satellite Systems and Applications. So far we have discussed different segments of GNSS systems, different GNSS constellation systems, their advantages and associated errors and how these errors can be removed. Now during that discussion we have also discussed very briefly about applications, how where we can apply the signals which are being received from these GNSS constellations. But in this lecture and in the next one, we are going to discuss in detail about the applications of GNSS. So this is part 1. In next lecture, we will be discussing that is part 2. So as you know that in general, what the purpose of GNSS is to these receivers to use collect position basically for positioning, and of course then velocity can also be estimated, and time information which is used for various applications. So generally this is what the main purpose of GNSS. We also know that there are some applications where frequency based information or the frequency which is available from GNSS systems can be used for calibration or some other scientific applications. So there also some GNSS applications are there or being developed. A lot of new applications are being developed. We are going to discuss in these 2 lectures the applications which has already been established or are being used. But there are many future applications which are being developed, which will be coming also in future. And also we know that all the purpose of all these receivers which are built specifically having applications in mind, that is initially basically the navigations. And many of such inbuilt navigation systems have already been incorporated in car navigation and etc. This is mainly in civilian domain. In military domain, of course, there are different applications, some which we know directly. We will be discussing those as well. So initial objectives, as we know, that the first few GNSS systems like GPS and GLONASS, one from USA and another one from former USSR, they were mainly developed for military purposes, but later on the signals were made available to civilians. So now different types of services are there for military and civilians. The other GNSS systems also developed initially for military purposes, but when countries realized that there are commercial applications or commercial viability of that one for sustainability of such systems or further development, so the signals are being also provided to civilian domain. So as you know that most of these signals may not be very precise one, but there are, because different services are there, but all these signals are freely available from these GNSS constellations. And in recent years the receivers have also become very affordable. We know that even GNSS receivers are coming with the not very expensive smart mobiles as well. And this technology has pervasive use in civil, industrial, scientific, military and many other applications like games and other things also. So in sports also it is being used. Which are the critical GNSS applications? This now we will start seeing, but before that there are GNSS applications which range from non-critical to highly critical applications, where the system would like to highly reliable on these GNSS applications or these GNSS signals. So different critically GNSS applications are there which lead to different performance requirements from the GNSS system. Once we go for apply these GNSS signals for some critical applications, then the reliability or the performance requirements expectations are very high. And definitely, because once the system have been put there, which has to rely on these signals, then everything should work properly. And these are GNSS applications we can group in terms of criticality as safety critical applications and liability critical applications, and the third one is the non-critical applications. So we can categorize in these three groups, and one we will be also seeing that basically for LBS, which is location based services, are there, and these services includes applications that depends on user location to provide a service information that is relevant to the user at that particular location where user is situated or standing. And this location based services use mobile devices, which is very common nowadays, with positioning ability to provide the service or information to the user. Like we use the GNSS signals, and in the background we are having a map or a satellite image like Google Map, and then we navigate using these signals also. So that, but may not be our movement or our services may not be that critical as maybe for some construction purposes or maybe for military purposes. So there are different types of location based services are there, like location based information streams which are required for certain applications. Tourist information, that is another very common application of GNSS signals or constellations, and nowadays also it is being used to manage the fleets by the owners, for taxi operators and so on, so for transport on demand, etc. Transport on demand like these taxi companies Ola and Uber, and there are many companies Grab and other things in other countries. They are extensively using not only the GNSS signals along with the GPS and other communication techniques which have been integrated in few applications, and then their use have become very friendly and very extensive also. And because of such location based services in transport sector, many times we feel that these taxi services have also become cheaper because they are optimally utilizing all the resources to run these fleets. In civilian domain of applications, that one of the most uses of GNSS systems is different types of civilian applications are there, like in personal applications which we use for our navigation and other things. Road applications are there, aviation applications are there, rail applications in the rail transport also they are implying, like in India. We know that slowly all engines of Indian Railways are being installed with GNSS devices, so they can transmit their location to a control center, so that everyone can know in future hopefully that where that particular train or that engine is standing. So this is another application in that one. In road applications, there are two ways it is being used, one for the navigation, another one is of sharing the location information. So in that way, if two people are connected to each other, then they can share their locations to each other. They can decide for how many hours or minutes they would like to share that location with each other, and this is how one can get updated information about a particular person through this. All this is coming through mobile technology and Google Map. And of course, in maritime applications where in water navigation and other, these GNSS signals are extensively being used. And also in industry applications, like if there are from one point to another point a fixed transportation is required, then vehicles can be programmed accordingly. And maybe in construction industries also, for large construction industries, GNSS applications are being developed so that many processes can be made automated. There are this list is not exhaustive, so there can be a few more applications which has not been listed here, but are being developed. They are becoming prudent, and few more will come in future in this list. We also used in scientific domain, if we talk about that, then we also use GNSS signals in surveying and mapping, and of course in GIS also. As you know, that in surveying you require very precise locations for mapping certain facilities or features, whether it's a topographic surveying or just surveying in urban areas. So a simple standalone GNSS receiver may not be sufficient to achieve that kind of accuracy which is required for a particular kind of surveying. But surveying like in geological mapping at say 50,000 scale, a standalone GNSS receiver might be sufficient, which may provide accuracy of 3 to 5 meter. But if one has to go for a mapping kind of applications, then we require more precise location information, and therefore a standalone GNSS receiver might not be sufficient. So for such requirements, one can go for very high end dual frequency multi constellation receivers, or maybe for DGNSS or RTK, or some other services which are there like satellite based augmentation techniques and other. But it depends on what is the precision required. If it is millimeter accuracy is required, then there are solutions. If meter accuracy is required, then there are solutions. So all kind of options are available in case of surveying and mapping, and of course in GIS. One of the very good applications which have been developed, which we will be discussing in detail in this lecture, is in the application in the geodesy, where crustal deformation studies, the GNSS have been employed. Very precise locations are required, and differential GNSS have been, or RTK techniques have been employed there, and by which we have been able to estimate that in which direction these different plates of earth are moving and what is the velocity and other things. So that discussion will follow soon. We continue on this the surveying, that increasing number of national governments and regional organizations are now have started using GNSS measurements on the basis of their geodetic networks. You might be also knowing that like even the census department, they too have started in recent years using these GNSS receivers to put a location and then attribute informations about associated with that particular location, so that the database becomes highly reliable, accurate, and can be used for various purposes. Because once a location is attached, and that can be attached through these GNSS receivers, then that information really becomes very useful, which can be analyzed on a GIS platform, and a lot of new products can be generated, which are being done also. As mentioned that for different types of surveying, mapping and GIS applications, GNSS receivers are being used, like for land surveying, mapping in GIS, aerial surveys also, and again this list is not exhaustive. So this lot of applications are also being developed apart from the geodesy, which we will be discussing in detail. So GNSS systems are originally, as you know, they are designed for earth-based positioning and navigation, and though that was the main purpose, but spacecraft navigation also they are also using spaceborne GNSS receivers, and which has become a very common way of getting locations, and also using low Earth orbits and geostationary orbits of different constellations, which allowing satellites to self-determine their position using GNSS. So the entire GNSS concept is based on satellites, but the other satellites can use these constellations to determine their own position, which are not meant mainly for a GNSS constellation, but for other purposes, maybe for communication or maybe for spying or low Earth orbit for high resolution satellite data acquisition and so on. So for their position determination, the GNSS signals can also be used by satellites, though GNSS itself is a satellite-based navigation system. And that if such satellites starts using GNSS signals, then their dependency on ground stations reduces very significantly. And of course, the accuracy of their designed, how they have to move and to their designed orbits, that can be assessed and they can be put almost automatically in their designed orbit. So that is a new applications that satellite themselves are using GNSS constellations of different navigation systems for their own positioning. And a space community started experimenting the spaceborne receivers very early in the deployment of GPS network, and this was done very early in the when the Landsat 4 was launched in 1982. At that time, it was tested whether such systems can work in future or not. So, when we discuss the history of development of GPS or overall GNSS, we also touched about that first time in 1982 for demonstration and to assess the feasibility of such GNSS systems. At that time only the GPS was there. For navigation, this sensor or this facilities was added in Landsat 4 satellite, which was launched that time. There are different types of space applications are there, like precise orbit determination. That is the one of the main requirements in space-based applications, that whether the satellite is orbiting in that designed orbit or not. If not, then how it can be brought back to in that brought back into the precise orbit. And satellite real-time navigation also, it can be used. Satellite formation flying also it can be used. There are various scientific applications which we will be discussing in brief here, that offer important contributions in a variety of scientific research domains. And in recent years, significant progress has been achieved in to use new GNSS constellations like Galileo, Beidou, GLONASS, IRNS or NAVIC, and analyze the data available jointly with a growing variety of available measurements. And additionally, these already implemented GNSS systems are evolving and new systems are being developed. And of course, our position is getting improved. The position information, that is mainly XY, is getting improved. Signals are available in all parts of the world from multiple constellations. In other scientific applications, like in earth sciences, there is a lot of applications of GNSS apart from geological mapping to crustal deformation studies, in mining operations, and many other exploration work where a lot of field surveys are required. These GNSS receivers are being used extensively. Space-time meteorology also in a scientific domain that is being used. In fundamental physics also it is being used to study these delays in the ionosphere and troposphere, and how what is the behavior of these waves in these layers of the atmosphere, and there it is being used. And as it is shown through 3 dots, that again this list is not exhaustive. There are many other applications which are under development, and soon they will be coming in this list also. And particularly in earth sciences, because I come from earth science domain, so I am going to discuss a little bit about that part, and that in where in earth science it is being used. So as I mentioned that these GNSS applications are being used in ground deformation studies, and that is where millimeter accuracy positioning is required, and so highly accurate GNSS receivers are used, whether through DGNSS or RTK or SBAS. And there are a lot of global distributions of these networks are there, which are being employed to study these movement of the different plates of the earth, including Indian plate. And this studies of atmospheric effects that I have already mentioned, that is a sort of not only part of physics, but in earth sciences also. In the atmospheric sciences you can add, or which is a earth system science, and that is how the propagation of these delays through different atmospheric layers, tropospheric and ionosphere layer, what is the behavior and delays, these are also being studied. Also indicated earlier that such delays are being or the perturbances which occur before an earthquake, a large earthquake event, are also being studied through these accurate or DGNSS systems in different parts of the world. So, one of the examples which I am going to take from earth sciences field, which is very popular in that sense, and many people understand. So, in deformation studies, it is being used that as you know that the Indian subcontinent is one of the most earthquake prone regions of the world, as we can see that all along the Himalayan belt and some other parts in northeast and western part, we are having occurrences of lot of earthquakes in past 100 of years. As a list says that that if we look the past 100 years or so, that we are having a Kangra earthquake of 7.8 and a big one earthquake which came in POK of 7.6 in 2005. And of course, 2015 earthquakes of Nepal, which also part of this Himalayan or Indian plate. So, it's a very active, seismically very active regions of the world, and therefore, it is important to understand that how Indian plate is moving, in which direction, and where the stresses are being developed, whether they can cause or can bring some earthquake. And for that purpose, people are employing these DGNSS systems to study this thing that we will see soon. So, because it's a highly complex tectonics of Indian plate, especially the Himalayan part, there are large major fault systems are there, and in Himalayan collision zone, these faults are like main central thrust, main boundary thrust, and Himalayan frontal thrust. So, if we go from south to north in the Himalaya, deeper Himalaya, then first we encounter the Himalayan frontal thrust, then we encounter the Himalayan MBT, boundary thrust, and then central thrust. So, in that way, as you can also see in this geological cross section, that Himalayan frontal thrust or main frontal thrust is here, and after this Indo-Gangetic plain, then MBT is there, then MCT is there, and then Indo-Suchar zone is also there. So, that is part of greater Himalaya and the Tibet region. So, as you know that along these faults the movements occurs, and whenever there are some movements, the earthquake are there. So, precise GNSS geodesy makes it possible to understand the dynamics involved and measure the strain accumulation along major fault systems in Indian plate. That is the main purpose of this GNSS geodesy, which has been employed in recent years, and a lot of such stations have been established all over the India, and this triangulation methods along with these observations are being used. So, as you can see that there are various permanent stations spread all over the India. There is a large concentration of these permanent stations in parts of northeast, because northeast is seismically very active region. As per the seismological map of India, it falls in zone 5. Large part of Himalaya also falls in zone 5 and also in Gujarat, and therefore these monitoring of such zones is very much required, and more permanent stations are concentrated there. And there are several campaign mode stations which have been also shown here. So, under this national GNSS program, this is being done under the Ministry of Earth Sciences. So, by this so far what we understand that that the Indian plate is one of the 8 major plates of the world or earth. It is moving in towards roughly in the northeast direction with a velocity of about 5 centimeter per year. And where are the strains are being developed and how they can bring earthquakes and other things, that is a different subject altogether. But the main input in such studies is going through these GNSS observations, which is being done regularly through these permanent stations and campaign stations as well. As you know that the tensions are gathering, these means the strains are getting accumulated all along these fault lines, and whenever there is a rupture and when there is a break, the earthquake occurs, and this is what it is shown here. And the last, this is the one example of Sikkim earthquake is also shown, and as we know that recent years Nepal earthquake has also occurred, and these are showing that time and space of earthquake along Himalayas. So, the larger is there is more sort of you can roughly say the more strains are getting accumulated, and there are more chances of earthquakes and so on, and what different earthquakes have caused, those things have been indicated in this one. And that the velocity of Indian plate is also mentioned, that is roughly about 5 centimeter per year. Different parts of Indian plate are having some different direction movements and different velocity, but overall the average velocity of Indian plate is towards in the northeast direction roughly and about 5 centimeter per year, which is very significant for earthquake related studies. So, this GNSS based geodesy is giving a very significant contribution or input towards seismological studies. Other roles of GNSS, that modern GNSS allows measurement of strain accumulation as just discussed, which can lead to the earthquakes, particularly areas outside of various deformation zones, that is intraplate earthquakes also. And the analysis of GNSS series of measurements after earthquakes, that is the post seismic motion, reveals information about forces and material properties associated with that earthquakes. That means that whenever a large earthquake occurs, scientists also imply they go in the campaign mode, use the DGNSS systems to understand that how the forces were there and is still continuing, and what kind of material properties were associated with those earthquakes. So, not only before the earthquakes, but just after the earthquakes, that is post seismic motions, are also studied using GNSS systems. And occurrence of some earthquakes affect where future events will occur, and that is stress transients also is studied. So, these simple one can think a simple measurement through DGNSS, regular measurement, continuous measurements, allow to study lot many things about the future earthquake, past earthquake, and other things also. GNSS are also extensively used for to study the volcanic systems, especially to understand the precursory signals which might be coming through the volcanoes, a future or a sort of dormant volcanoes or maybe active volcanoes, and the pressure builds in the magma chamber when there is a build-up. If the regular monitoring through GNSS is being done, then sometimes even forecast is also possible, and which is being done for many active volcanoes of different parts of the world. And there are meteorological applications, and the GNSS measurements are not only for sensitive to positions of GPS antenna, but also a medium through which GPS signals or GNSS signals propagates. And we know that there are different layers in the atmosphere which causes delays, and by understanding these delays, we can also understand these layers also. So, a kind of inverse studies or inverse modeling is possible, which is being done. And there are three main contributions in meteorological applications of GNSS. That is the charged particle layers, that is an ionosphere, which can be studied, where the variations in the radio communications and power grids are there. GNSS networks can be used to monitor variations and warn on the common ionospheric storms for which we require dual frequency measurements. There are neutral atmosphere, that is oxygen, nitrogen mainly, and delays well modeled by surface pressure measurements. And third one is the water vapor delay. If water vapor is there in the atmosphere, then they also cause the delays, and GNSS receivers are very sensitive, or these signals are very sensitive towards the water vapor, and they bring vapor uncertainty in meteorological forecast models. So, for that purpose, GNSS can be employed to study these, and therefore, our meteorological forecast models can be made more accurate and reliable. So, in summary, what we see that there are primary applications in GNSS in earth sciences, that is in deformation measurements. Continuous operating networks supply direct measurements of deformation, but also support densification of networks using occasional occupations like in post-seismic studies, contribute to GNSS orbit determinations, which improves accuracy in region with continuous stations, can be used to support other GNSS applications with real-time telemetry of data. That means that measurements are being done, they are transmitted for some other, for maybe a control station or for some other applications also. So, that can be done, and for near real-time systems support meteorological applications in which you require a very regular monitoring. So, that can be also done. In earthquakes, volcanoes, weather systems do not know the political boundaries, and therefore, the science applications of GNSS can help everyone in a region. So, instead of concentrating mainly in the political boundaries, one can look a system and then can be studied. Various parameters of these systems in a regional basis can be studied while employing GNSS. So, this brings to the end of this discussion about the application part 1, and in next lecture we will be discussing part 2, applications of GNSS. So, as usual, again I am leaving with a cartoon for you to smile. Thank you very much.